Welcome to the project demonstration of three-phase power transformer protection microcontroller based relay. So in this project we are going to protect these transformers. Here we are using 1:1 transformers, can handle up to 3 amps of power current, and there is the load. So when the load is increases, that will be identified by our microcontroller. Based on that we set the limit in the programming, and when it crosses the threshold value, then automatically the system will switch off the power supply to the respective load by disconnecting the power supply using this electromagnetic relay in order to protect the transformer from overloading effect. So here we are demonstrating for the three-phase power supply. This is R, Y and B phases. So each phase consists of 1:1 transformer 1 and 2 and 3, and for each phase we are using one current transformer. So the CET will measure the currents on the respective transformer, and it will be informed to the microcontroller through this potential divider circuit. So for each phase we have placed the each circuitry. So this consists of potential divider. Initially there is a resistors to drop the voltage, and thereafter one DB103 IC, which is the IC version of full wave bridge rectifier. After that we will get the pulsating DC, and there will be 1000 microfarad capacitor to remove the pulses to make the pulsating DC to the smooth DC, and thereafter again one more potential divider circuit we are using to get the voltage in terms of 0 to 5 volts only. So that will be given as input to the our microcontroller at A0, A1, A2 pins, and then based on that signal from these potential divider circuits we are going to control this electromagnetic relays. So these three relays are connected at C1, C2, C3 pins, and the so-called status continuously displayed on the 16:2 LCD screen, which is connected at pin number B2 to pin number B7. So with the controller we are using is PIC16F72 microcontroller. So the power flow is directly, so this is the R phase inputs, and this is going to be the Y phase inputs 230 volts, and this is B phase inputs. So when we provide the 230 volts, let me explain you for one phase. So here we are providing 230 volts AC inputs. So in general, like 1:1 transformer, nothing but input 230, output also 230. So we made the 1:1 transformer by using two 3 amp transformers, which is of 230 to 12012. Again here you are using 12012 to 230 volts. So the output from the transformer 1 given as input to the another transformer secondary coil. So primary you will get the 230 volts. So that will be given next to the CET in series, again relay also in series, and then the bulb. So when we place the bulb here, the respective current will be identified by this current transformer. The output from this current transformer given to the potential divider circuits, and from there to the microcontroller, and based on that it will control the relay, electromagnetic relay. From these cables we are going to get the trigger inputs to this system, to this relay. So on this relay board we can see one LED which will show the status of this relay, and next transistor to get the triggers from the microcontroller to control this electromagnetic relay. So based on the controller input to the transistor will switch on the relay will allow the power supply from this 1:1 transformer to this load. The same operation for the remaining two phases also. So let us see the demonstration. So we need to on the first R, Y and B, and again main power source input to our microcontroller, so which is main operating the inputs and outputs, right. So now the so-called status will be displayed on the LCD screen. Status is R phase, Y phase, B phase. Three are normal. So let us place the abnormal condition for the B phase. So after around 5 to 10 seconds of duration, the system will scan the reading from this potential divider circuit through the CT. Right, now the power supply got isolated, and the same alert message displayed on the LCD screen: B phase overload. Till you reset the system, so it's keep on off state only. So manually we need to check the status on the transformer overloading, and then we can reset the system. Again go with the Y phase. R phase is normal as of now, remaining Y and B are the overload. Right. So the R phase, B phase and Y phase. Remaining three phases are abnormal. So now let us reset. The reset nothing but this is a reset switch to reset the microcontroller from the initial. Right. Now as of all the loads got switched on, and now again it will scan the load on each and every transformer. Right. Right.